Okay, so I need help with 11, I need help with 12, and then we'll go over what we need to go over so each one for your city, okay? And your group can get a point. They both had to be negative in order to get that positive 6, because negative 2 times negative 3 had to be positive 6. Minus 2 minus 3 is minus 5. That's very good. It took first a few minutes on that one, and you can't see what I'm doing. It took first a few minutes on that one, so I'm impressed y'all got that quickly. Number 12 is a good one because it is the cubes one. Yeah, I heard 5 say the words. Did you say the words 2 page? No. I didn't think so. 5 get a point. Okay, and so it needs to be, just lay it down there. I need to have a binomial and then a trinomial. What needs to go in the binomial? What needs to go in the trinomial? Ooh, it is 2x and 5, but it's same sign, opposite sign, always positive with SOAP. So sadly, your sign's wrong. Otherwise, yes, perfect, Jack, and continue. I give you the 2x and the 5. Finish it, you can have 2 points. It's not just an x squared, though, is it? It's a 4x squared. And then what? Somebody step in and help him. He can have the 1 point. Someone step in and save the day. What do I put in the middle? What do I put last? Oh my goodness. Thank you. Thank you. And you can have your point, Gilberto. Okay, every single time it's been this same format. Now, I'll give you that, but we already tested on this, people. I'll give you that it's a little more complicated when there is a number other than 1 in front, but still, 8 is a cube. 2 cubed is 8. 125, 5 cubed is 125, so it's still the same process. 2, 5, this squared, which gave us 4x squared, this squared, which gave us 25, and the middle was this times this, so the middle was 10x. There is a cubes on the test tomorrow. Okay, let's talk about the test. Well, let's do 13 and then we'll talk about the test. Okay, 13. Let's graph it. It says a computer manufacturer determines that the profit for producing X computers per day is this. What is the meaning of the zeros in this situation? So let's graph this function. The negative 0.000x6, x4. Graph it and tell me why you're mad at the graph. Why are you mad at it? It's a snake, and we thought we were going to have an M because of that negative leading coefficient. 2, you said it first, you get your point. Thank you, 5, for finishing. You can have a point as well. So we end up getting this. Wait, I thought since it was a fourth, I was supposed to get a W and an N. That's a cube. So darn you, real-world application problems for, not sticking to my normal graph pattern, first of all. But there is some good news and some bad news, so let's talk about this graph. So again, it's supposed to be the profit for producing X computers per day. So like, this is 1 day, this is 2 days, this is 3 days, this is 4 days. Every single dash on the x-axis is a number of days. Okay, so first things first, if I'm above the x-axis, that means I've made money, I've made a profit. If I'm below the x-axis, that means I'm losing money. I'm not making a profit. I've lost money. And that does happen to a new business or whatever. So it's not uncommon to lose money. So we're either gaining money or losing money. But what are we doing exactly when we cross the x-axis? Because it asks for the meaning of the zeros. So what does that mean in the real world? We're what now? Yeah, we're not gaining or losing. What would that be called? It's neutral, or you want to say neither gaining nor losing, or neither making nor losing money, or there's like a financial term for that. It's not that deep. It's called the blank point. No. Like a business term that implies what's happening there when I'm neither making nor losing money. Because again, a new business expects to lose money for a while until they hit that point, and then after that they expect to make money. They call it the break-even point. Because that's where you broke even. That's where you were going bankrupt, and now finally you're going to make a profit. Okay, so if you put any of those words down to describe a situation, they're fine. And there's good news as well. So we were originally mad at this graph because of this part, but I can actually cover this part up entirely given our scenario, our real world scenario. Now in real life, sometimes parts of the graph don't even count in the situation. Why can I cover up this over here on the graph considering this real world problem? You can't have negative what? What is going on the x-axis? Well, you can sell negative products. Cooper can start a company selling hair bows, and then when he sells 10 hair bows and never actually sends them to anyone, there were 10 hair bows that never happened. But there is something that can't be negative, and they tell you in the problem. They tell you about what the X is for. They say computers per day. So that means this x-axis is involving time, and unless suddenly you've got you a time machine, we're not going to have negative time. So that's why we can ignore this part, is because we're dealing with time. Now you can make a negative profit, and like we're discussing, Cooper can make negative hair bows by promising to make some and never making them, but you can't have negative time. It's impossible. For now. Okay, so that's lovely. Let's talk about your test tomorrow. There are 10 problems on this test as well, which, yeah, that's it. Let's look at your study guide and we'll talk about what 10 they are. There is one that's going to require you to use words. It is not a real-world situation, but it does require words. Okay, let's look at your study guide because we want to correct something. Okay, so there are 2 problems that involve synthetic division, or synthetic substitution is what we call it, but really, you use synthetic division, the remainder is the answer. And you have to use synthetic division. If you actually plug it in and evaluate, you didn't follow directions. There are 2 problems like this where they tell you one of the factors and you figure out the other factors. There are 3 problems where you find all the zeros. And then there are 2 problems like down at the bottom. And if you would please get rid of that square root symbol. I do not want that square root symbol on 13. Okay, so this is actually what we were talking about yesterday. There will be one like 13 with real numbers, but there will also be one like either 14 or 15 that has imaginary numbers. So that's what we got to briefly discuss today. That way you can do at least. That's not a big deal. So far we got 3, 4, 5, 6, 7, 8, 9 problems. I'm telling you the last problem, it gives you a graph, and then it wants you to use your words to explain why the graph is what it is. So it's back to what we've been talking about forever. I knew that, like on our profit example, I was mad because it was a cubic graph, and I thought I was supposed to have a W or an M because of the 4th power. Like it's literally you showing you do know how to do graph things. It's not a big deal. And then so you're super annoyed because you're like, Miss Compton, that's 10 problems, yet you still have cubes on the study guide. It's true. One of the graphing problems has a difference or a sum of cubes. I'm not sure if it's a difference or sum. Has a cube thing in it that you have to know how to do. Theoretically. Theoretically. Because all of this is still theoretical because as we've discussed before, while we've been doing notes, we did notes for 3 days on Where are you? On what page to do, how she should use synthetic, how she should then maybe do grouping and figure out the 4 answers or whatever. And then we discussed there was a cheat. Paige doesn't necessarily have to do any work whatsoever. What can Paige put on her paper so I know she's competent, but she doesn't have to show any work whatsoever? If you use something about your graph, I used my graph and found the things. There's at least one problem where Paige literally doesn't have to show math because she could figure it out using her graph. But it requires Paige to have some good graphing skills, and if there are 10 problems and 10 points each, and she's wrong on that problem, and there's no work to show, so you have to be pretty confident with your graphing skills. Okay, yesterday we did page 23. It's the page before the study guide. We did 1 and 2. Don't know why my 2's gone. We're not doing 4 or 6, but we are going to talk about 3 and 5 really briefly right now. So we're talking about how much easier it is if you have to go backwards. Like, man, instead of me being given a really long function and I have to find the zeros, it's super fast if I'm given the zeros and I find the function. So we worked an easy one yesterday that involves all real numbers. Today's involves complex, hence the 2i. Okay, so we're still going to think things through the same way. I know there's an x plus 1 because of that minus 1. I know there's an x plus 1 because of that minus 1. Now, maybe I'm smart enough to begin with to go to x plus 1 squared. We pray, but you know, it's okay if not. It happens to the best of us. And then I know since I have a 2i, I also have an x minus 2i. I'll bring him down. But imaginary numbers, if you look back over every single problem we've done lately, imaginary numbers are like girls going to the bathroom. They always come in pairs. Always. Every single time. We've had a plus or minus 3i, plus or minus 4i, plus or minus 7i, plus or minus whatever. It's always plus or minus. So yeah, we've got the plus 2i, and we automatically get for free the minus 2i. No, they don't bother to list it. Yes, we are just supposed to know. If you get one, you automatically get the other. So on number 5, they gave us the minus 3i. For free, we get the positive 3i. So yes, I've got x minus 2i, but I've also got x plus 2i. Okay, so I could FOIL all these things out. If I go back to this step and I FOIL that out, x squared plus x plus 1, I would have x squared plus 2x plus 1. If I FOIL this imaginary guy all the way out, I would have x squared plus 2ix minus 2ix. The middles would die. It would be plus 2ix minus 2ix, and they would end up canceling out. And then last, I would have minus 4i squared. And you're like, Ms. Compton, they did not give us enough room for this. No. We're going to talk about how I do this a lot easier way in just a second. Okay, so I brought the pink thing back down. I can simplify this. I know what I squared is. What is I squared? Say it again. It's negative what? Yes, so you're right. Get your point. It's negative 1. We're supposed to remember that. I squared is negative 1. So negative 4 times negative 1 is positive 4. So I actually have x squared plus 4. Perfect. Okay, well, sadly, you and I both know I'm still not done. I've got to give that x squared to everybody. X squared times x squared is x to the 4th. X squared times 2x is 2x to the 3rd. X squared times 1 is just x squared. And then I shared the x squared. I got to share the 4. 4 times x squared is just 4x squared. 4 times 2x is 8x. 4 times 1 is 1. And then I really would love some like terms to combine, but sadly, these two are the only similar people. So I end up with x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 1. Now, is this easier than being given this and you find the roots? Yes. Was it still a little time consuming? Yes, hence why there's only 10 problems on the test. I'm going to show you a way I make life faster in just 1 second. But let's talk about all the mistakes Paige could potentially make right then, because there were a lot of mistakes. Paige could have foiled that one wrong and not ended up with this pink thing. Paige could have foiled the imaginary ones wrong and not ended up with that orange thing. She could have simplified wrong with the imaginary numbers. She could have not distributed well and never ended up on this line, or she could have not combined her like terms well. There's a lot of mistakes that Paige could have made within that one problem, which is terrifying because your test is tomorrow. I understand that. So, as always in life, wouldn't it be smart of us to check this with our graph? Why not go and graph this function, so x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 1, and I graph it. And I've done something wrong. Let me see what I typed in. Y equals x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 1. I've typed something wrong. I hate it when that happens. Someone else have a different graph than me? What have I done wrong? Between class periods. X to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus. Miss Compton did not distribute well. Can someone tell me where Miss Compton's mistake is for 3 points? And you can have 3 points. 4 times 1 is 4, Miss Compton. No wonder your graph didn't look right. You didn't distribute well, like I'm telling you. Whew. Now I'm happy. Now I'm super happy. Why are you happy? Because remember, our zeros were -1 twice. I see the -1 twice because that multiplicity with the hump. And then our other 2 answers were imaginary, so I'm not supposed to see them on the screen anyway. So I graph what I did at the end and make sure it matches the zeros I was given. Okay, well, Miss Compton, and you can do it just like that. So on the next one, if Tylen wants to, she could do x plus 3, x minus 1, x plus 3i, x minus 3i, and she can FOIL and distribute and work all the things out to end up getting her answer. If this is a 10-point problem, Tylen's going to get at least 6 or 7 of her points for just doing this. Because I understand life's hard and people make mistakes on the bottom part. But if I'm being honest with Tylen, I don't even do this. I don't have to write this part the way I did. So let's pretend. So number 3, let's face it again. So we had on number 3, -1, -1, 2i, -2i. I don't have to do as many steps because I understand what gives me those answers. I don't actually have to do x plus 2i, x minus 2i. Instead, I know that to get those answers, because we've worked a lot of these problems lately, so I've noticed a pattern, it always ends up being x squared plus whatever your perfect squared is, so 2 squared is 4. At some point we had this. That's how we ended up with the x squared equals -4. That's how we ended up with the plus or minus 2i. And if you're smart enough to realize, hey, x squared plus 4 is what gave me that plus or minus 2i, why not go straight there? So again, Tylen doesn't have to think like me. She can work it all the way out and be a creature of habit, and I understand that. But I've worked so many of these lately, I understand that's what's happening. So for instance, on number 5, with its -3, 1, -3i, +3i, I knew, yes, x plus 3, x minus 1, I can't avoid those. But I know this one is going to be x squared plus 9. Because, again, in my head, I've already thought through, normally when I have x squared plus 9 equal to 0, that's when I get x squared equals -9. That's when I get that plus or minus 3i. So if you feel the way I feel, which is I've worked enough of these lately that I understand this gave me that, then you don't have to do some of those intermediate steps that we did just a second ago. And you can save some time and definitely some brain power. Now, if you don't know what the world I was just saying right here in pink and orange, you need to work it all the way out. There is only one like this. It's not that big of a deal. Again, AJ is going to get 7 out of 10 points probably for just having this line. It's just, does he want the 10 out of 10? And he does, for him to continue to work it out and end up getting an actual polynomial. Are there any questions about that? It's pretty deep for Thursday. Okay, then go work on